welcome to this event. So I'm going to talk a bit about, from a fairly high level, solar activity, what it is and why we find it important, and why I'm particularly fascinated by it and why I care about it. And we come to you talking from the open source satellite program, where we want to make space more accessible through the development of an open source microsat platform and community. We do a series of talks once a month. It's about the cadence we like to do on a wide range of topics. So I'm trying to remember what the last talk was on. It was architecting the open source satellite is what we spoke about just before Christmas. And this one, January's talk, I know we're now in February, is something just a little bit more of a departure, just something just so that we can learn a bit about the sun and why we care what it does to satellites, etc. But we do other talks, and next month I'll come on and talk about a bit more about next month. That's going to be something more on skills, etc. So who am I? So I'm a system engineer working on the open source satellite program. I'm working at KISPE, doing system engineering and a whole range of things. And one thing that I do as a system engineer quite a lot is power modeling, and also delta V and drag modeling, looking at end of life and maintenance and things like that. So that's where I come across solar activity, and so why I've got a bit of an interest in it. So we're putting together, I suggested doing this talk because I'm really interested in the topic, and also just find I'm fascinated by looking forward and how the activity of the sun varies. So what am I going to cover? I'm going to talk about what solar activity is and the solar cycle, and predicting the future. I said as a system engineer, I'm looking at things like deorbiting satellites, orbit maintenance, etc. And actually understanding what's happening with the solar cycle is quite good to know, and is involved in some of the modelling that I do. So understanding, predicting the future of solar cycles is quite important. And then I'll go on to why it is important. Okay, so, and there's another picture of the sun taken very recently. So solar activity. So we look up into the sky, and when we actually get to see the sun, which obviously at this time of year isn't as often as we'd like, it feels fairly constant, and it doesn't feel like it's varying a huge amount. But the sun does show periodic variation in activity, and that variation was first postulated back in 1761, with the first solar cycle first being identified in 1843. So we've been monitoring the sun for quite a long time. And in 1852, the first numbered solar cycle was designated as starting in 1755, based on earlier observations. So we've been counting solar cycles since 1852. But we can do even more than that in terms of understanding what's been happening in the sun by using carbon-14 radioisotope ratio measurements. It's also been possible to reconstruct the solar cycles for the last 11,000 years. So we've been monitoring the sun and what it's doing for quite a long time. And just as an illustration, here on the right, I've got a couple of videos of the sun. So the top one was taken on the 17th of January this year. And then the bottom one was taken in mid-July in 2019. And I hope you can see and agree with me, there's quite a big difference between these two images. The top one is showing quite a lot of activity, coronal loops and things like that, and flary type activity, whereas the bottom one looks very, very quiet. And the significance of the dates when I took these will become apparent as I go through. So we have a solar cycle, but where does that come from? Why do we have a solar cycle? And it's produced by a dynamo mechanism driven by the energy of plasma flows inside the sun. And the sun has this large-scale dipole magnetic field stretching from one pole to the other. And every 11 years, these poles swap. So the north goes to the south and the south comes to the north. So every 11 years, and then therefore producing an 11-year cycle, which is like half of a 22-year cycle if you think that the north goes to the south and then 11 years later it goes back up to the north again. So we talk about the sun having this 11-year cycle. So so that is what's driving this solar activity that we see. So how do we measure the solar activities? Well, there's a number of ways. The most common one, and the one that's been done for the longest period of time, is the sunspots. And that's how the first activity levels and cycles were measured, by measuring these sunspots. And I'll come on to what a sunspot is later. Then there is a radio flux measurement in the F10.7 centimetre band. That also, the radio emissions also vary cyclically. And then solar observations and measurements looking at flares and that kind of activity also gives you a feel for what's going on. But the main one historically that we track is the sunspot number. And here on the picture below, you will see a couple of charts. The bottom chart showing the count of average daily sunspot area over a particular hemisphere, and the chart above is actually mapping where those sunspots are on the sun. And you can see there's very clearly a cyclic behaviour occurring. And I've got more charts on this as well. So what is a sunspot? So sunspots are darker, cooler regions on the surface of the sun that arise due to the disturbance of the sun's magnetic field, which because of the disturbance in the magnetic field, it's inhibiting convection in those regions, which is causing this cooling down effect. And they're sort of temporary spots that are just that bit cooler than their surroundings. So, and they appear in active regions, often in pairs of opposite magnetic polarity, and they, in the numbers and locations of these sunspots, will vary with the solar cycle. Individual sunspots or groups of them can last anywhere from a few days to a few months, but they do eventually decay. They can expand and contract as they move around the surface, and they can have sizes that vary from 10 miles in size to 100,000 miles inside. So, and the larger sunspots can be visible from the Earth without even the aid of a telescope, and may travel and they travel around with different relative speeds of a few hundred meters per second when they first emerge. And these sunspots indicate regions of intense magnetic activity. So, and they can accompany other phenomena in the region, like coronal loops or prominences or reconnection events. And most of the solar flares and coronal mass ejections will originate in these magnetically active regions around visible sunspot groupings. So this is why sunspots are a really good way of measuring activity on the sun. And we've been tracking, and you can see them almost by eye. You can look at them through telescopes, providing you've big health warning. Don't just go and get a pair of binoculars and go look at the sun. You need to use a filter, a really thick filter. You can get special filters to block out most of the sun's light, and then you can actually see sunspots. Or you can project as well. That's another technique. But again, you've got to use these correct filters. Otherwise, you will blind yourself. So please don't go looking through a telescope without any filters. Look it up how to do it properly and safely. And it's a good example of where citizen science can come in, because, if you've got only needs a fairly small telescope or a pair of binoculars, and you can actually track sunspots, and obviously has been done for a long time. So, and what happens is we have the peak of sunspot activity coincides with solar maximum, and the lowest sunspot activity with solar minimum. And they travel from higher latitudes down to lower latitudes during the solar cycle. So they're a really good measure. And these two images here are showing you can hopefully you can see sunspot regions. The top one is fairly current because, for solar maximum, and the bottom one is taken at the same date as the earlier image I showed you earlier video, which was taken back in July 2019. And July 2019, we were nicely in a solar minimum, and now we are coming into, and they're predicting that the next solar maximum is this year. So so we're heading into it now, which is why it's particularly interesting to do this talk now. So here's just a few images of sunspots in various levels of magnification. So you've got the big solar view there, and you can see how sunspot regions travel around the sun. The video doesn't show an awful lot of change in that particular sunspot region, but you can see how in some cases, you probably can see a bit of how they grow and evolve in a different region. And when you look at them more closely, you can see they've got quite a lot of detail within them. You've got a very dark region, the umbra, and then a penumbra around them. So a really fascinating phenomena and a good way of tracking solar activity. So this should be a video. Oh, yep, this is a video. So this is just showing how, if you look carefully as the video plays, you will see the dark regions, the dark and the white regions are showing the different poles. These are the visible sunspots that you can see, and then how that correlates really nicely with where the active regions are. So, and if you look over to the right, you can see there's dark and the two different polarizations. Then you've got the spot, and then you've got the active region. So you can see how they tie very nicely in with activity on the sun. And this video is available from the SDO. So I think the majority of the videos I'm showing here today are taken from the Solar Dynamics Observatory by NASA. If you Google and go to their website, you will find a wealth of solar imagery, and you can get a picture of the sun from today. So you'll find today's image already up there. So go and have a look. It's a great resource, and it shows lots of different wavelengths, magnetograms, solar disks, different wavebands to show different effects of what's going on with the sun. And I've got another video here, which is again showing similar things. So again, another SDO showing how the sunspot regions tie in with activity on the sun. So here, the sunspots there's some activities that aren't directly visible with sunspot. So, so it's not a perfect correlation, but it's not bad. And here we've also got, showing all the magnetic field lines as well, showing how complicated that magnetic field structure is. So, and as I said, so the sunspots also don't only just vary in number during the solar cycle, but in their position on the sun as well. So they tend to start at solar maximum at the higher latitudes around the 30 degrees north and south, and during the cycle will gradually migrate down towards the equatorial region, and at the same time gradually reduce in number. So there's not just a total number change in sunspots, but actually where they are on the sun is also evolving. So that provides a wealth of information. So we want to know what is happening with the sun and the solar cycle, so we do monitor. So every day the sunspots are measured, and there's a whole series of observations that go on, which are collated by the Royal Observatory in Belgium, and they produce a sunspot index and long-term sunspot index, and they do a monthly mean sunspot number, and they calculate a monthly mean. So if you go onto their website, you can track this plot here. This plot was downloaded yesterday. So each month they build up this plot showing what the activity is for that month. So I'm quite often at the end of the month going and having a quick look and going, oh, I wonder what the activity was for this month. This month was quite active, but around 125 sunspots. At solar minimum, they're around 0 and very low values, and they can get much higher than this with really active cycles. But I'll come on to that in the next plot. So they gather all the data, and then that data gets correlated, input into other models. So here is data from NOAA. So they do a solar cycle progression. They have a really useful website showing the solar cycle, and you can analyze it in more detail, zoom into different regions. You'll see a couple more of their plots in a minute. But this plot is showing here the solar cycle and the sunspot variation for the total number of cycles that have been monitored and numbered. So when I spoke back to the first cycle starting in the 1700s, so this goes back to there, and it shows, hopefully you can see, there's quite a wide variation in activity for the sun from one solar cycle to the next. So like cycle 3 was pretty active, as was cycle 19, which was also pretty active as well. The last solar cycle 24, was actually a really mild solar cycle in terms of activity levels. So, going back to, probably about, if you look back, cycle 12 would be a comparable one. So a really low level of activity. So, whereas the cycle before that was much more active. So, and I will come on to why we care about that in a bit. But so since 2000, since about 2005 or so, we've not seen a very, very active sun. So what's going on with this cycle? So I'm showing on the plot here the sunspot number and the F10.7 flux. So the two charts just show how they're pretty well correlated with each other, and showing where this cycle is going so far. So there'll be another data point appearing today, probably, for the solar cycle, for the sunspot number for January, which is about 125. So it'll be up around here somewhere. So this cycle looks like it's going to be a little bit more active than the last one, but not probably at the level of, I wouldn't say it's going to get to cycle 23 kind of levels by the looks of where it's going. So, and the chart there is showing the NOAA prediction, which I'm going to come on and talk to you about in a sec. So, so it shows how it's going. Predicting what's going to happen with the solar cycle is pretty hard. So, so the previous chart showed the latest NOAA prediction, which is an international panel, NOAA, NASA, ISS. So they do a prediction. They did a prediction back in 2019, which is shown in this chart. And then there's another prediction shown on this chart by another group who were analysing the data in a slightly different way and looking at where the termination event from when the magnetic poles switch, and using that as a way of tracking the activity. So a couple of years ago, I was looking into some solar cycle stuff. I was thinking, I wonder what this solar cycle is going to do. And I came across this chart, basically. And I was just fascinated by this is where we can sort of month by month track which prediction's going to be right. Or is it actually going to be in between, which it might well be in between. So it's not very, it's really, I don't know, I find it quite interesting, quite fun to see which group are going to be right. And it just shows that solar physics and solar modeling is it's a difficult job, and even the people that have been studying it for years and years and years, aren't going to get it 100% right. So if you look at this chart, this is the NOAA, the International Panel prediction. The grey is the error bars on that, and I think they have adjusted it recently because they know it is looking like it's going to be more active than they originally thought. So the solar peak is probably going to be, the red line was the original prediction. It's going to be a bit earlier, they think the peak is, and a bit more active. So so even the experts that have been studying this for years cannot get it 100% right, which is quite cool. But so there's a lot we've still got to learn, which is good that we're sending more missions, using more missions like Solar Orbiter and SDO to get more data to help us to get the feel for what is actually happening with our solar cycle. So why do I care about the solar cycle? Increased solar activity means increased radiation in orbit in the upper atmosphere. Increased radiation can cause satellite upsets. It can cause wear on satellite parts. Lifetime of components may be impacted. And when we're designing missions, we need to include the mission launch date and mission length in our in radiation modelling. Though I was reading, and I've still got a lot to learn on this sort of stuff. Solar flares and solar events can actually have a beneficial effect, though, on solar radiation, because it can push galactic cosmic rays out of the way. So so it can work both ways. Actually, it can have a beneficial effect, and galactic cosmic rays can be quite damaging, whereas the solar can be more easily blocked. So there can be positive effects as well. So in a radiation modeling, I would always include the launch date and when we're launching as part of the analysis. So this is using a tool called SPENVIS. It's just a tool available in Europe, provided by, recommended by ESA, and you can put in your orbits and your time of launch. And I've just modelled here a solar maximum case and a solar minimum case, just to demonstrate that you do get different levels of radiation. In this case, the solar protons, as one would expect, is much lower at solar minimum than at solar maximum. Why do we care? Increase in activity increases solar storms and events and CMEs, and a CME is a coronal mass ejection. So these solar radiation storms can emit fast-moving charged particles which carry lots of energy. They can endanger astronauts and Earth orbiting spacecraft. So during some of the storms, astronauts in the International Space Station may be asked to seek shelter, and extravehicular activities may be paused. So in the International Space Station, they can go into the Soyuz, or one of the labs is a bit more protected, so they can go in there. Radiation sensitive systems may need to be powered down until the radiation storm has passed, etc. So, and also there are interviews with ISS astronauts. They're not at great risk, and they haven't had too many incidents of having to go and shelter themselves, because obviously they designed it to cope with the level of solar activity. But they have astronaut on the Mir space station found that they were getting, where it had slightly less protection, were finding they were getting flashes in their eyes if they closed their eyes, and that was down to the increased activity. But we don't only see these effects in space. A big solar storm or event can affect systems on the ground. So back in 1989, there was a big blackout in Quebec, Canada, or even 2003, there was a blackout across the eastern US. And these solar storms can disrupt satellites, ground infrastructure, radio blackouts. In 1859, during solar maximum in cycle 10, this was one of the most intense geomagnetic storms recorded in history. And that was reported due to the strong auroral displays that were seen at the time, but also it caused sparking and fires in multiple telegraph stations. And this was back in 1859, where there was an awful lot less electronics compared to, well, none compared to what we have now. So a similar storm now, what impact would that have? So spacewalks would be timed to avoid space weather events and going through the SAA. So what other impacts are there with solar cycle? One that probably impacts my day job maybe more than most is with increased solar activity, it causes the Earth's atmosphere to puff out. It makes the Earth's atmosphere more dense and extend out to higher altitudes. So, and this leads to increased drag on a satellite. And that can have numerous, so increased drag. So if you're flying relatively low and you want to maintain your mission, it might mean that you need to do more maneuvers to stay up at the altitude that you want to be. Or if you were wanting to deorbit your satellite, then deorbiting in solar maximum would be slightly easier than if you were deorbiting at solar minimum, because you would be experiencing more drag. But whatever the scenario you're looking at, it's important to look at the launch date of your satellite when modeling any of these effects. And the strength of the solar cycle, and also the strength of that solar cycle will impact predictions for lifetimes and how quickly you would deorbit, etc. So I often use the ESA drama tool, which is provided by ESA for deorbit calculations and other collision risk type things, type analysis. And that model allows me to model a range of different solar cycles, so I can look at this impact. So here, just for an example, I've done a quick drama run with a satellite. This is a small satellite. It's a cube satellite, so it's got a fairly small cross-sectional area, about 0.4 meters squared. It's a small mass, it's 25 kilos, around 600 kilometers. And the first picture is starting in July 2023, so we'll be at solar max, going through the first part of its mission is going to be very much in solar max, whereas the second one I've started the mission in solar minimum. So, and this illustrates the range of answers you'll get by modeling a different case. So this is using the nominal, or the bigger, the middle cases here is for the current prediction of what we think the sun's solar activity is going to do, and then this provides like the edge cases like 95% percentile and 5% percentile on that data set. And we see that for solar maximum, the nominal lifetime is about 11 years, whereas it would last an extra couple of years if it was launched in solar minimum. And the minimum lifetime is a lot faster, 1.5 years compared to 4.5. Maximum lifetime does switch over, but the cycle is 11 years long, so it's all about how long. So where you start in solar minimum for the second satellite, it will go into solar maximum. And we'll go through solar maximum. So that's why you can see some variation on that. So this was done for the nominal predictions, but if I was to model different solar cycles, which I can do, I would get different answers. And the solar cycle does greatly influence what prediction I might get in terms of how quickly a satellite will deorbit. So ESA include, as part of the drama tool, what they call the ECSS solar cycle, which they've taken to be cycle 23, which, if you remember back to this chart, cycle 23 was quite a bit more active than what we're currently seeing. So so if you wanted to, so that would give you, in terms of a deorbit time frame, it would give you a faster deorbit time than what is currently predicted for our current cycles. So, but that is what ESA recommend at the moment. Okay, so, but puffing out the solar atmosphere can have quite big, devastating effects for a business. So this is a news article back from February 2022. SpaceX were launching one of their planes of Starlink satellites, and within a couple of days of launch, there was a big flare, big geomagnetic storm, which increased the density of the atmosphere by 50%. And what Starlink are doing is they're launching to very low altitude and then boosting their satellites up. But because of the magnetic storm and the atmosphere became 50% thicker, they didn't actually have enough fuel to actually boost the satellites up to their nominal orbit, and they ended up losing, I think, 39 out of 48. I think they lost 39 satellites out of 49 that they launched due to this one solar event. So, and it wasn't an overly remarkable event either. So, yeah, so the onboard GPS suggested the escalation speed and severity of the storm caused the atmospheric drag to increase by 50% higher than during previous launches. So what they tried to do was put the satellites into a safe mode, turning them to fly edge on to minimize the drag. But the drag was strong enough that the satellites couldn't get out of the safe mode and back into the orbit they needed to move up. So they lost a big number of the satellites in that launch. So I think better if they'd have known that the geomagnetic storm was coming, they might well have delayed a launch, and certainly they'll be watching for that in the future. So space is challenging. So, and also, and only through really researching this in detail, was the increased drag is it's not predictable. It's not in a predictable way, so it makes it tricky or difficult to track debris during and after a solar storm. So in October 2003, which was quite a long way after the solar maximum in cycle 23, satellite controllers did lose track of hundreds of spacecraft for days after a major storm hit the Earth. So because it puffs up the atmosphere, so the tracking where they predict the satellites or the debris is going to be isn't where it is, because the atmosphere isn't behaving the same as it was before. So there is a concern. We're coming into coming into solar maximum. We're in solar maximum now. A similar event now, and given the massive increase in the number of satellites and things in orbit compared to 2003, this is obviously quite a big concern. So they lose the track of them, so they have to basically re-find all the pieces again using radar. So that's going to be quite a big job, and will be quite tricky if it happens during this solar maximum coming up. So that's really interesting. And what else? Finally, can you see? Well, the one cool thing, or a cool thing of the solar maximum is obviously, well, not obviously, but with solar activity and the solar wind, it gets channeled by the Earth's magnetic field into the poles. And if there are big storms and events, there is a lot more material that goes to the poles and it pushes out further. And so what you get are aurora events coming much further south for the northern lights than you would normally see. So it allows people that wouldn't normally get to see, because aurora can be seen most of the time up in the Iceland and Norway, etc. But it allows people in more southerly latitudes to actually start seeing aurora. So this picture here, Stonehenge in Wiltshire, you're able to see an aurora. So there was an event back in October. I think people were able to see aurora events. So I'm kind of hoping that maybe this year, coming into solar maximum, I might get the opportunity to go to a dark skies area and maybe see an aurora. It'd be pretty lucky, because they're still not that common in the UK, but I'll hopefully head north and hopefully get a chance to see an aurora. So that's kind of what I wanted to talk about in terms of solar activity. I hope people found that interesting. So any questions I can try and answer? So if you're interested in the open source satellite, please just visit our website. You can find social media on there, where you can provide email updates and things like that. We do these talks every month, and we would love to host other people to do talks. So if you are interested, just get in touch. So next month, or actually later this month, we're going to talk a bit about getting into space, or the space industry. So not literally being an astronaut getting into space, but talking about how you might get into space industry. And so we're hoping to have a more discussion feel for that, and we're hopefully lining up an external person to help us with that. So if you have any questions or any things that you want to put into the discussion session, or you want to take part, please just get in touch with on the contact details in the next slide. So hope you found that interesting, and thank you very much for your time.
Thank you, Kathryn. Yeah, I thought that was an extremely interesting talk, with a lot of interesting facts about the sun that I knew nothing about. So that was an excellent talk. Thank you very much.
No problem. Fairly top level, I know, but I'm not a solar physicist.
Well, I was intrigued by the way that the poles. I did not realise that the poles on the sun flipped every 11 years. I knew there was an 11-year solar cycle, but didn't realise the poles flipped that quickly.
Yeah, they do. The Earth's poles flip as well, but it's a much slower timescale, hundreds of thousands of years. But yeah, no, every 11 years the poles flip, which is, when you imagine what process must be going on in the sun to do that, given the size of the sun, is quite remarkable. So,
do they? I know you're not an expert, but do they know? Have they got any concept as to why they flip like that?
I don't know, I'm afraid.
No, because as I say, I'd never heard that they flipped. I just wondered if they knew, but or whether they were still using these satellites to try and understand these mechanisms within the sun, which I imagine are hugely complicated.
I think they probably do know a bit, because it's there's a big dynamo and it's all very energetic. But I'm postulating, so I'll shut up.
That's all right. I'll just have to go away and see if I can find it out. So
there are things I didn't talk about. There are things I didn't talk about. Things like the Maunder minimum. So there was a period. So if I go back, and this is where I might get a bit on dodgy territory, but I think cycles 5 and 6 here, very low. There was a period called the Maunder minimum, where the solar activity was very low. And, people were ice skating on the Thames and things like that. So it actually had quite an effect on the climate as well.
That was the Victorian mini ice age.
Yes, exactly. Yes, exactly.
Okay.
Exactly. That was it. And the sun went through a very low activity level. And there was some debate around, with cycle 24 being quite low, whether we might head into another Maunder minimum. But I think the consensus is that's not going to be the case. And also, and cycle 25, if anything, is going to be a bit more active. So, but yeah, and that Carrington event, when was the date of that again? My memory's not all that great. Oh no. The Carrington event, 1859. So 1859.
It's around cycle 9.
Yeah. But it's it's not in the peak. There, looking at it, 'cause I don't know what the scale is, but yeah. So yeah. I think some of these, go on.
I was just going to say, because you also mentioned about the the carbon-14, and you can go back thousands of years. When they go back, I presume can they just tell the peaks, I guess, of when it happened.
Yeah, I've seen a plot that's quite similar to this one. So, but it just extends back further.
Wow.
So I guess there's probably more error in what the levels actually are. But yeah, they've been tracking it. They've been able to track back quite a lot.
It's quite incredible to go all the way back, because I was just interested to see if whether they had some very weak cycles, and whether they tied up with, as you said, we had the mini ice age in the 1850s. Did it tie up with things happening on the Earth as well? So it's fascinating.
Yeah, but most of the places I've looked at, and they've said about the solar cycle, it does not tie strongly to the climate. So we shouldn't get too excited of links between that and climate change.
Well, I guess you've got many things, haven't you? You've got what the Earth is doing itself, and then what the sun is doing itself, and there will be some interaction, but how strongly that interaction is up for debate, I guess. No, fascinating. Thank you. I now need to go away this weekend and read all about the solar stuff.
It is quite cool. Tracking this plot is my obsession. So I'm like, oh, maybe the prediction's right, said it, but the new point's going to be up about here somewhere. So, so yeah, it is citizen science almost. You can almost do it yourself, and that's always great fun to be able to feel that you're tracking some science yourself. And
well, it opens it up to more wider audience, doesn't it, and understanding and getting more people interested in the sciences. So that's always a good thing, I think.
Yes. So, and going back to this plot, and the difference is remarkable, isn't it, between solar maximum and solar minimum, if you ever want a more clear example of what's going on. So so, and you can see that these spots are the higher latitudes as well, so you can see how they track down. So and these plots are just beautiful. I could look at these all day. They're fabulous. So, anybody else got any questions or anything? Cool. Well, in that case, we'll end the meeting, and thank you very much for your time and participation, and join us again. What was it? The Thursday, the 17th of February, for a discussion on skills for space, whether that be school leavers, kids wanting to go into the space industry, or people looking to change industry. And we've got a shortage of we struggle in the space industry to get the skills that we need, and we shouldn't just look at training people up, but also looking at how we can train people from other industries to join our space industry. So hopefully those topics will get covered next time. Okay.
Kathryn, I believe the next meetup is the 22nd of February, the Thursday.
Is it? Oops, sorry, got the date wrong. Good.
That's all right. I've just noticed that on my calendar. Yes, the 22nd.
Okay, thanks, Clara.
That's okay.
Cool. Okay, well, on that, so hopefully see you all on the 22nd.